Today I'm going to be introducing you to science and talking about the scientific method. We're going to use the scientific method throughout this entire class, so it's going to be important that we are familiar with the steps that we're going to need to follow in order to do that. So first we're going to look at what is science. Science is basically the goal, or the goal of science is going to be to investigate and to understand the natural world and explain the events of the natural world. And then we're going to use those explanations to make some useful predictions or inferences. And we're going to talk a lot about observations versus inferences. We're going to talk a little bit about those later when we, right before we start doing lots of labs. We're going to do an activity with that. So we're going to look at the difference between predictions, observations, and inferences. Science is going to only deal with the natural world. And by the natural world, we're going to mean things that are natural, things that are not science fiction. So science fiction would be like things that we know are not true or that can't happen. So that's what we mean by the natural world. Scientists are going to collect and organize, and that keyword is organize, information in a careful, orderly way. And I have used wordage such as orderly and organized because it's very important that we're organized in science so that we can look at those patterns and then make useful connections between those events. Scientists are also going to propose explanations that we can test. So by doing that, we're going to take explanations and we're going to be able to test them and develop hypotheses. Okay? And science is going to be an organized way of using evidence to learn about that natural world. And the only way to do that is to stay organized and put things in a proper order so that we can look at those patterns in order to investigate the world. Okay, so how is science done? Okay, science is going to begin with an observation. And I talked a little bit about observations earlier. An observation is going to be anything that you can identify with, or any characteristic you can identify with your five senses. Okay, so that's your hearing, seeing, touching, tasting, and feeling. Okay, so those are those five senses. I almost forgot my five senses, guys. Okay, this is the process of gathering information about events or processes in a careful way. And when we develop that observation, we're going to gather data from that. So data is going to be gathered from those different observations. Okay, so let's look at the scientific method. One of the most important parts of this presentation. The scientific method is going to be a series of steps to keep a scientist organized to solve a problem or answer a question. Okay, so you're going to develop questions in here, and then we're going to find a way to solve that problem or answer that question. So we're going to look at those steps of the scientific method. I want you to keep in mind that in other classes they may use different words to describe their steps. But in my class, these are the steps and these are the words I want you to memorize, because there's going to be a quiz Friday on the scientific method. So we want to make sure that we know those steps in order. Okay, so it's very important that they're in order. First, we're going to find a problem, okay? So you're going to develop or find problems in the world. And from those problems, we're going to form a hypothesis. And a hypothesis is nothing more than an educated guess. And the key word to that is educated guess, because it has to be something that we can test. Then we're going to gather our materials so that we can design an experiment. So you're going to design and perform the experiment. And from that experiment, you're going to record some data. And from recording that data, we're able to look at what we gathered and those patterns and draw conclusions. So what happened from that? Does it support my hypothesis? And we'll look a little closer at that in just a second. So step one, we're going to look at a problem. So a problem or question must first be identified. And so these are different types of questions or problems that could possibly be answered. So how much water can a root hair absorb? So we'll learn about plants later. We may want to test that, okay? Why does a plant stem bend towards the light? We're definitely going to look at that. And then what temperature or what effect does temperature have on heart rate? So that's a very good question that you can answer, okay? Step 2, you're going to form a hypothesis. Okay? A hypothesis is a possible explanation to the problem or question. And you are going to want that hypothesis to be educated. Okay? It's that guess. Okay? It is simply a prediction and has not yet been proven. So we're going to prove that hypothesis through our testing or our experiments. Okay? It must be stated in a way that is testable. A statement is considered testable if evidence can be collected that either does or does not support it. So I'm going to teach you how to write testable hypotheses, and that's using if and then statements. If you write it in if and then, more than likely it's going to be testable. Okay, we're going to take a look at step 3. Step 3 is to gather your materials. Your materials are simply the things you're going to need to perform the experiment. There are different materials in here. I didn't list examples, but examples could include beakers, test tubes, eyedroppers. It can even include paper towels. So those are different things that you may need to perform your experiment. So step 4, we're going to design an experiment. Okay, you're going to write or follow the procedures that are given by your teacher. And I like to call myself a facilitator because you guys are also teachers in the class. Do not make up a step. Okay, so whatever is not written in the procedure, don't do your own thing. So whatever's in that procedure, I expect you to follow. That way you don't do anything wrong or anything that may hurt you. Step 4, you're going to record and analyze your data. This is where you need to be very organized, okay? Data, the data that has been collected, must be organized. And then we're going to analyze it, meaning we're going to figure out what it means. We're going to see whether or not that data is reliable. And basically by reliable, can we use that to draw a conclusion? Okay? So we're going to ask ourselves, does that data support or not support the hypothesis? So basically you're saying to yourself, was my hypothesis right or was my hypothesis wrong? And it's okay for your hypothesis to be wrong. And that's something you can explain in your conclusion. Okay? So we're going to draw a conclusion from from that data. You're going to use evidence from the experiment. You're going to tell whether or not your hypothesis is proven or disproven. If it's proven, your hypothesis was correct. If it's disproven, that means your hypothesis was incorrect. Experiments must be repeated over and over if you find that your data was not valid. So, after hearing all of this, what is a problem you might use the scientific method to solve? So think about something that you're wondering about, and then develop a question or some type of problem that you could solve. Think about that, write it down, and we'll come back together.